These are the notes about rivers and watersheds. The streams found in mountains are likely to have formed relatively recently. These young streams typically have V-shaped valleys. The rivers tend to move fast in their upstream portions because they're steeper, although some are slowed by large rocks and boulders in the river channel, just like in this picture. So at the top of mountains, it's going to be steep, and there are going to be a whole lot of big boulders blocking the way for these streams as they're beginning. The young mountain streams tend to have a steep slope, or what's also called a gradient. Hopefully you know that from math. Rivers move a great deal of material. The faster the water moves, the larger material that can be carried downstream. So the faster and more water that there is, the more of a push behind it that there is in order to move that larger material. Fast-moving upstream portions can often move rocks and boulders. Downstream portions usually only transport small silts and clays. So think about the particle sizes that we've talked about. Silts and clays are the smallest things that we can have. This process tends to sort materials by size. Have you ever wondered why we have so much silt and clay in our area? Valleys with very steep, almost vertical sides are called canyons or gorges. How long do you think it took to form the Grand Canyon? On your notes, I want you to write in how long you think it took to form the Grand Canyon. Most scientists believe it took 1 to 3 million years. It's probably a lot more than you figured it would have been. A stream or river cannot cut its bed any lower than the body of water into which it flows. As the stream approaches this base level, which is as far down as it can go, the slope and speed of the stream decrease. This also happens the closer the stream gets to the ocean or sea level. The river channel becomes wider, deeper, and the volume is bigger as there are more tributaries contributing to the volume of that river. So that typically happens the closer it gets to the outflow or to the ocean or maybe to a bay, wherever it's emptying. It's going to have more tributaries adding more water to it. Let's check out the little man in the boat as he goes down the stream. The river valley also changes at this point. It becomes more open or more of a U shape with a wider river floor. The lower or downstream portion of the river is at its deepest, widest, and slowest speed. It also has the largest volume and a very gentle gradient. So if you think about the way we're looking in the picture, when a stream starts out, it's going to be up here in the mountains. It's going to be very steep and small because there's not a lot of water to contribute to it because there's not a whole lot of water hanging out up here at the top of a mountain. As the stream gets larger and less steep as it comes further down the mountain, we're adding more water to it because maybe it's accumulating water from all three of these mountain peaks now. And it's coming down the side of the mountain. And the closer it gets to the outflow, the flatter it gets and the more water it's carrying because now it's taking water from this whole area and bringing it out somewhere at the bottom. The river valley tends to be broad, flat, and bounded by bluffs. These bottomlands are often areas that flood. These little peaks right here are what's called bluffs. And lots of flooding happens. If you think about New Orleans, they are actually built on a floodplain. That city is on flood banks of the Mississippi River. So if you think about this as being the Mississippi River, you've got New Orleans sitting on the edge. And anytime the Mississippi River floods, that water comes over the edge, over the bluff, into the floodplain. Lower portions of rivers often start to meander or form an S-shape river pattern. Again, that word is meander, not meander. Please don't say meander. Meander. So it starts out, and you're going to have to draw this on your picture because it doesn't come out very well. Water is coming down towards the bottom, and these yellow dots are where the river erodes. And the water is getting pushed there, so you're going to deposit sediment on the opposite side, on those red areas. And then water comes down here and pushes on this side to erode, deposits on that side because it's going to be slower, and then it keeps happening further and further and further until it becomes more and more of an S shape. And then eventually it'll even cut off and become what's called this oxbow lake, and it'll be straight again, and the whole process begins over. Erosion is greater on the outside of the bend, deposition more on the inside, and that's what I just said. And these yellow dots, that's erosion. The water pushes on the edge and erodes it, whereas it's slower and deposits sediment on the other side. The river can eventually cut through the meander, leaving a straighter section and an oxbow lake. And that's what's happening in this picture here. You've got deposits that build up on these red dotted areas, which makes this turn into a lake, so it's not even part of the river anymore. Rivers deposit the sediment they have carried as they slow down. This sediment load will often form deltas as the river flows into the quiet waters of a bay or gulf. You ever heard about the Mississippi Delta? That's where the Mississippi empties all of its water and all of its sediment out into this area that sort of looks like this, and then you've got the Gulf of Mexico around it. The river tends to be split into channels by its own deposits as it drops more sediment. As the deposits grow, they resemble the Greek letter delta, which is just a triangle, with the point of the river being at the top of the triangle, and then it fans out with all the sediment. Alluvial fans. An alluvial fan differs from a delta in several ways. The deposit is formed on land, not in water, and it's going to be from water washing down the side of a hill. And you can see how huge this thing is because that little tiny car right there is shown for scale. Also, the sediments of these deposits are coarse sands and gravels rather than fine silts and clays of the deltas. Because these are higher up in elevation, they haven't had time to wear down into the smaller, tiny silts and clays that delta will have brought down from higher up in the river.